Okay. Uh, this is chapter 4, elasticity, and it's an important concept. We'll build on it a little bit. And I've talked about it in the chapter 3 video. And this is an important concept. Let's suppose you have a business and you're trying to decide if you should raise your prices or not. Well, elasticity would tell you what that would do to your demand. So it's okay if you raise prices and you lose some customers, or some of you lose your a certain number of purchases, but because the price is higher, maybe you generated more total revenue. Or you find out that if you lower prices, you'll get so much more sales or revenue that it actually worked out to be a better deal. But until you understand the elasticity of demand for your product, and in this case, I'm referring to elasticity of demand, you can't answer the question and you can't make the decision. So, elasticity in a nutshell is the sensitivity of the quantity demanded to a change in price. In other words, as a buyer, as a consumer, how much am I affected by a change in price for your product? And that's going to depend on some of the things we talked about in the prior chapter. It can have to do with whether there are substitutes or not. And so there's a couple of things here. One is understanding elasticity, and number two is learning how to calculate it. So we might as well get started. And I'll start from the beginning. Yeah, and so even though we talked a little bit, or we saw a little bit about slope in the homework for week 1, which you're probably looking at or have looked at already this weekend, um, this is a related concept, but because we deal in percentage changes and the numbers on the axes rise and fall as you go up and down, the math changes the calculation of elasticity regardless of whether the line is a curve or a straight line, the demand line, the demand curve, I should say, whether it's actually a curve or not. So even though the concept of slope is related, the math doesn't allow us to use it accurately, because as you go out on the horizontal axis, the numbers get bigger and the percentages get smaller, and the same thing happens on the vertical axis. You'll see what I mean, but we have to distinguish between slope and elasticity in terms of the calculation and the reality. And I think I'm going to try to make that clear. The idea of slope gives us an idea, but it's a little confusing, and hopefully the graphs will demonstrate this. So the whole idea is, how sensitive is quantity demanded to price? That's it. And so they're talking about slope, but we have to use percentages instead, because in economics you could have um, increments on the price of nickels and dimes, and um, on the quantity demanded in millions of units, and so we use percentage. Notice quantity demanded is on the top. We want to know how sensitive that numerator, how much we buy, or in this case, the change in how much we bought, divided over how much the price changed. And so if, and this is one of the key ideas, we're going to define an elastic demand as one where if the price, the denominator, changes a certain amount, we're going to define the demand as elastic if the quantity demanded changes more than that. So in other words, it's sensitive to a change in price. Maybe there are a lot of substitutes, or, and this is an important idea because there are questions on the homework about this, when we have things that don't have substitutes, or things that we need and can't find substitutes for, like certain kinds of medicine, addictive substances, maybe on the short term, we have to drive our car. So in those situations, we're not going to change how much we buy or consume or use when the price changes. So if gas goes up 50 cents a gallon in 2 days, do you really stop driving your car and take the bus? Well, maybe some of you do. But what about the cost of important medical treatment or care? Or what if someone has an addiction to cigarettes or Starbucks coffee? I mean, I'm kidding with the Starbucks, but I mean, if they raise the price of the lattes 50 cents and that's part of your fix, your ritual, yeah, you're probably gonna, on the short term, you're probably gonna pay it. So the idea is that when there aren't a lot of substitutes and a good represents a need or a serious want that might be an addiction or craving of some kind, then the chances are it's going to be an inelastic demand. And what that means is that the quantity demanded doesn't change as much just because the price changes. And think about that. What I just said about gasoline, you're going to drive your car in the beginning on the short term almost regardless what the price is. So it's less than one because the percentage change in price is greater than the percentage change in quantity demanded. And if you know your fractions, you know that if the numerator is smaller than the denominator, it's less than 1. And so 1 is the unit elastic demand and supply. They both change by the same percentage. Elastic means that it's more sensitive. It changes, the quantity demanded changes more as a percentage than the price does. And inelastic is less than 1. And there's a trick to doing this, or couple tricks. And this is the kind of stuff that you just have to know. Okay. And so when we calculate the elasticity, we use an average price between the first and the second one. In other words, it changed. So what it changed to and what it changed from, we use the average for the price. And there's a reason for that, because you'd literally get 2 different answers depending on whether the price went up or down, and they're trying to avoid that. It's better, if you really want to know why, I can explain it to you maybe in a phone call. But the point is that we average the denominator to make this calculation so that it'll be the same whether your price is falling or rising over that part of the curve. And it's the same thing with quantity demanded. We take the average from the change over the amount of the change over the average. And you'll see what this looks like. But it's important because if you can't calculate it correctly, you'll get wrong answers. So this looks like a straight line, but the elasticity actually changes because the percentages change as the numbers grow larger or smaller. I understand that if we did take slope, it would be constant across that. And that's important that you know that. But for elasticity, we just have to do the math, and we're going to do some right now. So we want to know whether or not this pizza has an elastic or inelastic demand curve, at least for this part of the curve. So we know that it falls to 1950, and people decide instead of 9, now they'll buy 11. Okay? All right. Everybody see how the price went down $1 and the quantity demanded went up by 2 pizzas per hour. All right. All right, so we don't just go 1/2. We have to calculate the change over the average price versus, excuse me, change in quantity demanded over the average between the 2 points, average quantity demanded, and then the price, the change in price in the denominator. The change in price will be $1 over the average. And so you'll see what that looks like. Okay. Well, the change is, all right, now we're going to do the math. So the average, we did get the price change was $1, but the average price from 2050 to 1950 is 20, or halfway. If you need to calculate it with a calculator, just add up the beginning and the end and divide by 2. And the same, I think you can see now that the average quantity demanded is just going to be 10. 9 plus 11 divided by 2 is 10. So, all right, so remember we have the numerator is the quantity, change in quantity demanded. That triangle is delta, the Greek letter delta, which represents change. And so we have 2, it changed 2, and the average was 10. So I think it helps. I'm going to have to draw this because they're not making it look like it. So we have a formula here, and on the top is the percentage change in quantity demanded. Well, that is 2, it changed 2 over 10 because we use the average. And it's important that you realize how I got that. I just took 9 and 11. I can add them, 20, and divide by 2 is 10, or you can just know that 10's exactly. So this is the fraction. This was the change in quantity demanded divided by the average, and so this is the average. All right. All right, well, this is 0.2, is it not? 2 over 10. And you could say 20% if you want to do that. That's fine. They like to use percentages. And then that is the numerator. Remember, the numerator is percentage change in quantity demanded. The denominator is percentage change in price. So we actually have a fraction where the numerator is a fraction and the denominator is a fraction. So change in price was 1 and the average was 20. And so, by the way, I'm going to point this out here. Theoretically, demand, because it slopes down from left to right, elasticity is always going to be negative. It's always going to be a negative number, but we're depending upon the economics textbook in the class, we are going to just use the absolute value. In other words, we're not going to calculate it as a negative number. I'll show you, for example, the numerator, we saw the change in price was positive 2 over 10. And those were both positive numbers, so that would have meant this is positive 0.2. But In the denominator, the price change, the price dropped. So we'd actually say that 2050 minus, well, one of the two. We can say the price went down $1 and then the average was 20. So the point is that either the numerator or the denominator is going to be a negative number, because one of them has to go down and the other has to go up, because this is a line that slopes down from left to right. And you should recognize that it's an inverse relationship. So one goes down, the other goes up. And depending whether you're going, it's an increase in price moving up to the left along the curve or down, one of them is going to be negative, but we're going to ignore that's an answer to a quiz question, a homework question. The mathematical answer is always a negative number for elasticity of demand. But we don't use that in talking about it because it's only confusing. We're going to use, for this class and these purposes, we're going to use the absolute value of this thing. And so we got 20% over 1 over 20 is 5%. I just know that. And so this is going to be, it looks like 4, right? 20% over 5% is 4. And so the elasticity is 4 over that part of the curve. And since 4 is greater than 1, we say that this pizza, the market for pizza, has an elastic demand over this part of the curve from 20 to 1950 because it's greater than 1, okay? So you have to create a fraction that consists of a fraction in the numerator and a fraction in the denominator. Convert those to percentages, and then that's your elasticity. Greater than 1, it's elastic. Less than 1, it's inelastic. That happens to be equal to 1, it's called unit elastic. So this is about as complicated as it gets. Not quite. But this idea is simply measuring the sensitivity of quantity demanded to change in price. And it should make sense to you that I'd want to know this and why. It tells me the nature of the demand and whether the consumers are very finicky about price. Maybe there's a lot of other stuff like the potato chip example I gave. Why would I pay $5 for one brand when there's about 6 or 7 brands that make the same thing and one of them's, $1 cheaper? A lot of substitutes. Okay. And remember, demand for needs, things for which there aren't a lot of short-term substitutes, are inelastic almost by definition. I'll pay the price on the short term or whatever the change. So I'm going to keep, I think there's one more slide on here. Yeah. And we came up with 5% on the bottom. And so we got 4. Okay. And notice that they use the midpoint to calculate it. And that's because they use the average quantities and prices. So along that segment of the curve, the elasticity is 4. And we're using the positive number, even though mathematically you'll always get a negative number for elasticity of demand. And that is a question. You'll see it. Okay. Yeah, I mean, if I go back here, I'm not going to go through it, but you'd literally, if you didn't use the average and you just use the starting point on the denominator, you'd get a different number going from the original point to the new point than you would going from the new point to the original point. In other words, this average calculation is designed to make sure that when we're talking about the same stretch of curve, of the demand curve, we want to get the same number every time, regardless of which direction we're going. Okay. All right, and that's the formula. That's what we did. Change in the percentage change in quantity over the percentage change in price. And we refer to it as a units-free measure. And using percentages accomplishes that. Notice the minus sign. The formula, the mathematical formula, would give us a negative value. But we're only, for now, worried about the absolute value or the positive number. Okay, and that's a quiz question. So now I talked about this elasticity, and they want you to know this new language about being perfectly inelastic. Well, I said that if gas prices go up 50 cents a gallon, I'm still going to fill up my car. Well, what if I wouldn't change how much I bought no matter what the price of gas did, maybe on the short term? And so let's take a look. Perfectly inelastic literally means that I notice the quantity when it's vertical never changes. So that should match up with what I just described. I would still fill my car up, X number of gallons. I wouldn't change how much I bought, regardless of the price. And notice that the price goes, way up. And so perfectly inelastic means the quantity is always the same. It's like X equals something, if it were the old X and Y axis, okay? And then the unit elastic, the example they would give you is somewhere on that curve where it equaled 1. I'm trying to figure out why they're just looking for a place on there. I guess I can see where it might be. I could show you the math, but you can do it for yourself. And if the quantity demanded changes as a percentage less than the price, then it's inelastic. Remember, inelastic goods don't have as many substitutes. So I'm still going to consume a certain amount of that stuff, even when the price changes. And remember, inelasticity usually implies a need more than a want. I have to have this product, or I need this thing. Don't have a lot of choices. So this inelasticity tells us a lot about the nature of demand for a product. And this is perfectly elastic demand. And this may sound ridiculous. The idea is at 12, the quantity never changes. In other words, it can't drop at all. And the idea here is in a good where it's so competitive that I can I'm trying to think. Yeah, if I have a market, a big market for something, and it's very competitive, the first person to offer the lower price would get all the business. That's kind of what it means. So perfectly elastic is flat. If inelastic is almost vertical, then perfectly elastic is, for all intents and purposes, horizontal. And those can happen in situations where there are specific kinds of competition. We'll examine that. Okay. And so I kind of covered this. Income, um, this closeness of substitutes, I talked about that. I think that makes sense for you. The proportion of income spent. So, in other words, let's suppose that I have to spend a lot of money on housing and I spend a big percentage of my income on that. Well, that's an example of a time when I'm going to be really careful about, what kind of a price I pay because it's such a big ticket item for me. And that should make sense. The things that we write the biggest checks for, we're going to pay the most attention to. The time elapsed since a price change, um, I don't know if we're going to get into that. Let's go into these one at a time. I guess we are. Yeah, if a luxury usually has elasticity. If we don't need it, a luxury is almost by definition something we'd like to have maybe, but don't need. And so if you remember what I said about needs, things that we need are usually inelastic. Things that we don't need are usually elastic, and luxuries are an example of an elastic demand. Necessities are usually inelastic, and then the more time consumers have to adjust to a price change, the more elastic it is. Yes, and the example that I gave was with gas was, yeah, I mean, for the first week, if gas prices went up $1 a gallon, you might pay it and bite the bullet, but the next week you might start asking if anybody wants to ride share. You might look at bus routes. You might ride your bike. Who knows? So the more time you have to adjust, the more elasticity. That should make sense. Here is the math behind how elasticity actually changes even though the curve is linear. And it's just mathematical. It's like I explained, the numbers are getting bigger on the horizontal axis. So the spaces between them might be the same width on the graph, but mathematically they represent a smaller percentage. In other words, the difference between 20 and 30 is bigger than the difference between 40 and 50 percentage wise, but on the graph it's the same width. Okay, and it's the same thing with the price. As I go down the price axis, the differences, the width is the same, but the differences as a percentage get bigger. So there's a point, every point on this graph would have a different elasticity because of the mathematics. And they usually talk about the midpoint of the curve being elastic above that and inelastic below that. How you find the midpoint is a good question. I think it would have to be the halfway point on each side, probably the best way to explain it. And they give you examples which you can go through. I'm not going to go through them. Do remember, though, and notice as they do this, if you want to review this yourself, that we still calculate the change divided by the average. And that's what they did here. And so they show you an example of how right at that midpoint, and notice that they use the 2 points equidistant or equidistant on either side of it, that when they calculated it using that formula we went over, the fraction came out to 1. Now, this idea is important from some remarks I made earlier. Total revenue is a function of price times quantity, right? So if you want to know what your sales were, all you have to do is say, well, how many did I sell? And what was the price? That's total revenue. So when the price changes, the trick is, did the quantity compensate for that? And elasticity would tell me whether or not it did. And as I said, total revenue will only increase due to a change in price if the demand is elastic. And that should make sense. If you've got a head for math, you should realize that any number multiplied by a fraction that's less than 1 would be a smaller sum. And if demand is inelastic, well, that was the description I just gave you. If demand is inelastic, revenue is going to go down because you're multiplying times a fraction that's less than 1. So revenue will increase as long as demand is elastic. And that's a good example, because if you had a business and you wanted to increase sales and you knew where the elastic part of your demand curve was, you would lower prices up until you reach the unit elastic point, and your revenues would increase. Yeah, and so these definitions, that fact of total revenue, whether it's increasing or decreasing, and which depends on whether the part of the curve is elastic or inelastic. There's some definitions in there that they turn into quiz questions. So you have to know this fact about total revenue. It increases as price falls during the elastic part of the curve. Total revenue does. And total revenue decreases along the inelastic part of the curve when you lower prices. So you can see where this would be useful. And so all they're trying to point out, this graph shows how, as you moved along the different combinations of price and quantity along that curve, what they're doing is they're taking the quantity times the price and turning it into this parabola. And so it's just a graphic representation of total revenue. And what they're trying to point out is that at the apex of that parabola, 25 pizzas, total revenue has peaked. And now, as you increase quantity, you'll be moving into the inelastic side of the curve, and total revenue will be falling. So just remember, this is just a mathematical representation, or a graphic representation of the mathematics we saw over here. All we're doing is plotting a number of points. I'll get out my drawing tool here. So we're just plotting a bunch of points here. I don't know, here and here. And we're putting them, and we're multiplying price times quantity. And because the pizzas are, 20 times 25 is 500, I guess. So we're taking all those points and we're putting them in graphic form like this. And so 25 times whatever the price was equal 300, and that sounds about right. So clearly, yeah, they're trying to show you that 25 pizza level is where the demand curve begins to go from elastic to inelastic. And so you'll see now, going back to the total revenue curve, that we're actually, sales are going down once we get past 25, because now we're getting onto the inelastic part of the curve. I hope that makes sense. There isn't a lot of elasticity on here. It's a useful idea. As you can tell, you can If you can understand the nature of the demand, then you can answer questions about whether you should raise or lower prices and so forth. Okay. Yeah, I mean, they're beating this thing to death. Let me see. Yeah, okay. There you go. That's it. This is a good graph because it shows you that after 25 pizzas, you'll actually start doing less total business when you lower prices. So, yeah. Yeah, and there's just a little math in here, and I don't know if not everybody can jump from a graphic representation to the math that it represents, but if you can, good for you. Now, remember, elasticity is a kind of, it is a fraction, right? And if it's less than one, then you're decreasing, and which is less than one is inelastic, then anything you multiply times that is going to get smaller, has to. Okay. Now here, this is a related concept, but if you get elasticity so far, this should make sense. We talk about income elasticity because now we want to know how much the quantity demanded changes to respond to a change in income. So in the denominator now, we're not going to have price, we're going to have, or I should say, we're not going to have change in price, we're going to have change in income. So in other words, if I get a raise, how is that going to affect how much of, some Starbucks I buy, or gas, or some kind of shaving cream or something, even though I'm using an electric razor. Okay. So the difference here, we still have the percentage change in quantity demanded, but in the denominator, we have percentage change in income. So instead of saying, what is the sensitivity of this good, of this demand for this good, to changes in income, not to changes in price. And now we're going to get into that idea of the inferior good. Yeah. So normally, the more money you make, the more stuff you buy, or the more of the stuff you buy more of, you're willing to buy more of the stuff you buy. But if the income elasticity is less than one, then it's an inferior good because now that thing that you bought was bought deliberately to save money. It wasn't necessarily what you wanted to buy, but your budget compelled you to buy it. And so now that you're making more money, you don't feel compelled to buy it anymore. So an inferior good is something you buy when your income levels are lower. Okay. And that's the test. It's income inelastic, less than one. That should make sense. Cross elasticity, again, elasticity is a sensitivity, and we can compare the sensitivity of quantity demanded of a good to the price, of the good to someone's income, and we can even compare it to the change in price of another good. And imagine you have a car dealership, and you have electric cars like Hondas or Teslas or something, and you also have maybe you're interested in what happens when gas prices go up. Do you sell more of the electric cars? You should, because it makes them relatively less expensive to operate, right? So elasticity is sensitivity. We're still going to have the change in quantity demanded of something that we are interested in. And then we're going to see what happens with changes in something else that might affect us, like as I just described, the price of gas or the price of a competitive a competitor's good or a competitive product. Okay. And it's the same thing. We just change the denominator to represent the percentage change in the price of a substitute or complement. And don't forget, we're probably always going to use that same methodology where the numerator is the actual change over the average between the first and the last, where we started and where we ended up. And then the denominator is also going to be the change divided by the average from where we started and where we ended. And we're going to, you can do it on your calculator as a percentage, or you can just have them as decimals and convert them at the end to percentages. But once you divide a percentage by a percentage, you're just going to get a fraction. And it's either going to be greater than 1 or less than 1. And occasionally it'll be equal to 1. Okay. And this should make sense. So if I have the change, if a substitute changes price, then I'm going to have the point. The point here is that I'm going to change mine in the same direction. We saw that earlier, right? If the other thing goes up, then mine's going to go up too, because mine will be cheaper until people buy enough of mine to make it the same price. So that makes sense because we know substitutes move in the same direction. The demand for a substitute goes up when one of the other products in that group goes up. And a complement goes the opposite way of a substitute. You could almost stop there. But if you wanted to, you could reason it through. The thing that I have to buy the blades to use my razor, and so if the blades go up, I'm not going to buy as many razors. It's a similar kind of idea, but substitutes move together, complements move the opposite way. Okay, and so pizzas and burgers, I guess I fell prey to the fast food analogy or metaphor or whatever. Okay, so burgers are substitutes and the prices go up, so so pizzas are going to go up, and it's a shift in this case. The price of the burger went up, but it creates a change in the nature of the demand for pizzas. So it's a change in demand, even though prices of burgers went up. And that might have just been a change in price for that, but this is a change in demand for the substitute. So then, if people always drink soft drinks with their pizza, the demand for pizza would go down as soft drinks got really expensive. And that should make sense. I would not want as many pizzas if I had to pay a fortune for the soft drink. Okay. The opposite. Complements and substitutes move in opposite directions. Okay. We're getting close to done. Okay. Let's have a look. Okay, so supply is the same idea. It's just the sensitivity. Okay, let's take a closer look. This elasticity of supply is the same thing. You just substitute the word supplied for demand. All right, let's see how this So once again, perfectly inelastic and perfectly inelastic. We'll notice that perfectly inelastic is always vertical, whether it's supply or demand. Yes, if you remember. That that's a useful thing to know. There'll be some questions. That'll get you some questions answered. Okay. The thing about elasticity of supply, they talk about companies producing the same thing. In other words, um, can the company shift their resources to produce products that use the same equipment, for example? If they have more time, yeah, um, they can adjust more quickly. Okay. So yeah, if the wheat and corn analogy here, probably useful. Let's see. Yeah, on the short term, firms can't change um, how much they produce on the short term immediately. Short run supply is somewhat elastic. So the idea is I've already produced, I'm in production and I've got people hired and equipment running, and I'm going to put it out there on the short term. And of course, long term, I can make all kinds of changes. Okay, this is an example of a good chart to have handy. I mean, while you're taking a test, print something like this out. I think it's in the book. It's obviously labeled Table 4.1, so I'm sure it's pulled from the book. I know your brain can overheat playing with all these relationships. In some cases, you're better off just learning the, memorizing the relationships, like substitutes are positively related directly, and complements are negatively. Otherwise, you can reason it out as if you were a consumer or a producer. Okay. All right. I'm going to share this as chapter 4. And